my presentation into deep learning. And as you already know, deep learning is one of the subset of the great big family of artificial intelligence. And I will even dive even further as we're really going to address the time series part of the deep learning, and more precisely the deep reinforcement learning. And really, what can time series apply with deep reinforced learning could do for different type of organization. And there is many organizations that have time series data, and usually it's a kind of a untapped mind of data that could be used to generate a lot of value for different type of organization. There's good, really three example that's going to be included in this presentation, two high level and one where we're going to do a deep dive. So you're really going to see um, how can we generate value with time series data and artificial intelligence. So a quick look back of deep learning, which is a subset of the AI. It's really not new. Like many things, the perceptron, which are the fundamental pieces of a neural network, really came to exist in the 50s. The propagation, which is an essential part of the neural network, really concept was brought forward in the 70s. And things like recurrent neural network, convolutional neural network, all these were created or conceptualized in the 80s and the 90s. So it's not new. The big issue back then was the fact that computer was just not there. Like we didn't have any cloud. We didn't have like the cost of storing data was so high that really you wanna collect data and store it. That was a big issue just on the cost side. And the computer side, as you know, in the 80s, it was great to play Atari, Space Invader, but you want to run a neural network, even the mainframe was not able to do that. So that's why that kind of concept was great on paper, but really not going anywhere. It's really starting in 2010 that we start to have the capacity on the technology side to play with these tools. And when you look at the granularity, it's really from 2015 that we really had the full democratization of it. Tools like TensorFlow, PyTorch, which are free. You could download them yourself and you could play with them, and your own computer at home could run them. Actually, it's better if you have a gaming computer, but you could run that in your basement, basically. So that's the big thing that suddenly people started to play a lot with these things, and of course, organization. I think one important aspect is when you look at the field of application. So what people are working on right now using deep learning, but more specifically time series data. You have all of these fields, and I'm not going to name them all, but what we're going to focus today is the control field, so one of the last field. And that control field is really the one giving you autonomy. So we're talking about autonomous car, and that's the example below. Autonomous car is about autonomous control. So the AI is basically controlling the car and using the predictive capability, figuring out what should be the next move. So a typical car, and there's hundreds of them being tested around the world right now. You're talking about 48 neural network in one single car, doing about 1,000 distinct prediction. And what is a prediction? Well, you see it on the screen, right? We want to predict uh, each of the moving pieces, what will be their next move. And once you know the next move of all of the pieces around you, you could figure out your own strategy of what is my optimal strategy based on the fact that all these things will be doing these things in the immediate future. So we're talking about 70,000 hours of training. So you could have a car basically working, functioning on the street without doing anything that you don't want it to do. So one very important aspect that a lot of people forget about deep learning is yes, you hear everybody saying we need a lot of data. So yes, you need a lot of data, but it's not just about the majority or the quantity of data. It's about the different data type that you need. So the best application that you could think of It's really about the sensor fusion that I call. So if you're dealing with a time series situation where you're collecting data at each time stamp, so let's say every minute or every 15 minutes, um, you want to have a lot of data for that moment. But you want to have different representation of the same reality coming from different type of source of data, and that's collection of different source of data coming from different type of the data source about the same time moment, that is enriching your data enough so the neural network could have a good prediction of what will be happening. So the more the neural network understand about the environment and what's happening from different type of reality, the more it will be able to do a good job at practicing and training, and then eventually telling you you should now press on the pedal of the brake, because that is your optimal decision right now. So that is all about what we call sensor fusion. So application results. I really like this slide because it shows what type of result can you expect if you play with this technology. Um, and it's probably the most important question you have to ask yourself before you embark on any type of project is basically, what are we trying to accomplish here? What is the value that we want to extract from that uh, project, which is going to be applying a lot of data, a lot of work, and then neural network? What are we trying to do? So the bottom part here is what I call like the known results. So it's results that you already know. You would be able to come up to the solution if you start to do a lot of calculation using pivot table in an Excel sheet, using a lot of macro. You would be able to come with the results, but the AI will do it much quicker at a lower cost than if you do it yourself. So it's what I call the known type of results. Think about operational efficiency. So we want to detect that fraud. So there's a fraud in your system. You want to detect it. If you spend the right number of hours, you will find the fraud, but the AI will find it in a couple of seconds at a very low cost, right? Customer efficacy. So what is the price that you should put that product? At what price should you put it on the shelf? What is the optimal price based on the behavior of the customer today in this city? Um, so that you could be able to figure it out yourself, but AI will figure it out very quickly, more efficiently than you will. And of course, it will increase your revenue. So think about cost reduction, increase revenue. The top layer is what I call the more esoteric part. It's unknown, so you don't know what the AI will come up with, and you might be surprised by the results. So operational discovery. So give me a new process that will basically conduct the way I'm deliver this product in a different way that will be more efficient. But I really don't know if there is one new process that is doing that. So explore and bring back to me new ideas. Customer discovery. It's about product development. What is the new product you should develop? What people will want to buy tomorrow, next month, next year, and where? Um, it will not tell you why, but it will definitely tell you what product you should develop and where should you market it. So this is like unknown. You're asking the AI to discover things that you don't know. So let's go into like a three example, so you could really put some meat around that bone that I'm describing in these four quadrant. Um, Remy is an autonomous software that was deployed in a retail chain in Australia. Um, and it's basically studying the customer behavior. So you have to feed it a lot of data, especially point of sales type of data, and it will, through the times series, start to predict what will be happening. So it sounds like not that interesting as an application, but it has all kind of ramification which are quite fascinating. So think about basically how many product of each item you should put in which store. So you never have like a gap where customer are walking into a store, they want to buy this item, but there's no more of it. It's back order. So you eliminate that kind of situation, because you always have the right quantity at the right time in the right store. And you also eliminate the overstock where you basically have too much of that product, and then you have to start to discount. So that's the first level, the kind of incentive that, yeah, of course, the AI could do that. But then the next level is fascinating, and that's a fascinating part. Is basically telling you, well, if you want to do a discount, you should discount this product at 16% and not 25. So you're not guessing anymore what discount should you give on which product. The AI is telling you if you put it at 16, it will be sold by tomorrow afternoon. So then you start to optimize your margin by managing your discount and your markdown in a very, very precise way. So you always optimize your flow of goods and, of course, the conversion in dollar in money. So that really created like a completely a new situation for that retail chain where suddenly they're becoming so efficient. And the beauty of it is like in this COVID situation, the neural network is adapting itself. It's basically recognizing the pattern are changing, and it's basically giving you exactly how many quantity you should send in which store, considering the COVID effect and the government is starting a lockdown in that city. And that's the fascinating part is the capacity to self-learn and self-adapt when the environment keep changing. And that's not a small advantage for that retail chain. Another example is really fascinating. So we, as individual, we're pretty good at putting on the internet or CV, right? If you think about LinkedIn, we're very good at very precise. We say we worked at this company. We had this position. Here was our responsibility. If we receive award, we're very good at putting them. We also do a lot of posting. So we're basically telling a LinkedIn, here's what I like, here's what I don't like when I'm posting things. And that's a fundamental new thing that we're basically giving in terms of data, because we're basically telling who are we, or persona. So this application was done in Canada, and it's using most of the LinkedIn page, which are readily public. And it's basically we ask the neural network to say, and then you look at this table here at the bottom of the slide. We basically ask the AI saying, well, right now we have a senior project manager at Fidelity Investment, and we have a software architect, which is, by the way, the tech lead at the Bureau of Labor of Statistics. And we basically want to know, okay, these two individuals, first of all, are they happy where they are? Are they going to stay there, or are they going to leave their job to another job, either internally or external to another organization? And if they do, what will be the organization name, and what will be the project, if you want the title they're going to have, what department are they going to go work in that new organization? So here what you see is the senior project manager did indeed leave within the year, and he went as a project manager at Southwest Airlines. And the neural network predicted that that person will leave, and he will leave at either American Airlines, Southwest Airlines, Epsilon, or Bank of America. And that was the top 5 recommendation. And also, if he leaves, he will go work in one of these positions, and you see the position projection from the neural network. And it's fascinating because it really he went to work, that person, to Southwest Airline. He stayed as a project manager, so no big surprise. Really, the big change was the fact that he changed organization, doing the same thing he was doing in a different environment. The second example is much more compelling, because not only the person did change and did went to one of the 5 organizations that was outlined by the neural network, but he did change in terms of department. So he went from a software architect to a consultant, a more customer-facing department. And that was predicted too by the neural network. So imagine that tool being used by either the human resource in an organization, which you want to know if your employee is going to leave, think about retention strategy, and why are they leaving? What do they want to do really? And think then at the other side of the table of a headhunter that's using this tool to figure out, I mean, I'm looking to fill out this position as a headhunter. Now, who should I approach? What is the best fit? So that's a very powerful example that's being used. Um, so it's very hard for the human to compete with that type of technology because it's just too good. We cannot do that as a human to guess that type of thing that precisely. The other example is the graph above. This is a tool that is basically projecting in an organization how many people they will hire and what type of people will they hire in the next few years. So it studied the company behavior and it basically start to predict what will be the employment or basically the layoff. So it goes both ways. So this is actually the company that I created, and I've been following their projection. Now we could start to maybe wonder, are they influencing me in their hiring strategy, or it's really happening? But I could tell you that this is very, very accurate. So we are reaching now 70. So the projection is not that good in the sense that we're hiring more than the projection, but the ramp up and the speed of the ramp up is quite accurate. So that's another example. So you want to know if an organization will grow or will not grow, you could use that tool to figure out if you should invest or not into them. The last example, or we're going to do like a deep dive, is in the field of heating and cooling and ventilation of buildings, what we call the Hvac, which is a system which is exactly like your home. No matter how big the building, it's a reactive system. And I put this graph here to show you that as the temperature rise in a room, eventually it becomes too hot and the thermostat will decide that now you're becoming too hot, so I'm going to start the cooling, and then the temperature will come back down. If it's too much of cooling, it will go back down and trigger the heating set point, and then the heating is going to start, and eventually it will stabilize. So that's a reactive environment. The homes are managed this way, the hotels are managed this way, the office tower, the airport, it's around the world all managed in this reactive manner. What's interesting is if you could use the AI to predict what will be happening. So instead of letting it go and trigger that cooling set point, you basically want to know in advance that this is what's going to be happening in that room. And knowing that future, well, you want to do preemptive actions. So you're changing that future for a better future. So yes, you're spending still energy to do that correction early on here at this stage, but you're using a lot less energy than if you let it go, and then you have a much bigger correction to do to reestablish your temperature in your room. So you're spending less energy, and for the user of that room, there's a better comfort as you're never going too high or too low at any given time. So we're talking about precision. So this is what a deep learning LSTM network could do for you. So this is a retail store in Montreal, and it's basically the first. If you look at the aqua, so the aqua color curve or trend, it's basically the prediction. It's not only predicting for the next few hours, but it's predicting the temperature behavior for the next 2 weeks at a fascinating accuracy. And then what you have as the kind of military green is the real temperature movement as it's moving toward the future, as we're going to that future. So you see the accuracy. So we know exactly what will be happening in terms of temperature in that store days in advance. Now, for cooling and ventilation, really, I don't need days in advance. I just need a few hours because there's no point to know what's going to be happening in 4 days. Really, what's important is to condition the temperature right now. So this technology now has been deployed in many buildings around the world. And it's bringing in on average about 25% reduction of energy. But the interesting part is also improving the comfort of the occupant by 60%. And this is something you plug and it's learned and it's ready to start working within 2 to 3 hours. So would be feasible to do it with an Excel sheet and a lot of engineer time, but definitely not in 2-3 hours, and the cost will be quite different. So how does it work? How does it do this? Well, there's a sentence that we use in our team, which is that it was actually Isael that brought it. Is deep reinforcement learning is to control what deep learning is to prediction. So yes, you want to predict, but prediction is good. It's just telling you what will be happening, but you really want to control to optimize. And it's that combination of trial and error that we call the deep reinforcement learning instead of just the deep learning. So here in this case, there's really like four axes that you want to optimize, and you want to optimize these four axes at the same time. So the first one is the temperature. So you want to maintain comfort. So the people want it to be in between 20.5 and 22.5. So you want to maintain your temperature within that band at any given time. And every time you go out of that band, well, it's a failure, right? The second axis is the quantity of energy you will be spending. So these cubic meter of natural gas, these kilowatt hour that you're spending, that your equipment are spending to maintain that temperature. So it could be a ventilator, it could be a chiller, it could be a heat pump. These equipment are consuming energy, and their job is to maintain the temperature. The third driver is the peak power. So in most of the place around the world, the utility will punish you if you're using too much of power at the single time. So we call this the peak load. So if you're starting all of your ventilator at the same time you're starting the oven and all that, you're creating a peak, and the electrical company will basically punish you for doing that at the end of the month by charging you for that peak load. So you want to lower that peak load so you could give a break to the electrical company, give a break to the planet, but save money also. And the last one is the cycling. So the last thing you want is you don't want that fan to stop start all the time. You don't want to have these stop start, because these stop start is called cycling, and that cycling is damaging the equipment over time. So you will need to replace that fan over time. So you want to make sure it's all at any given time managed in a smooth way so you're not destroying the equipment. So we're basically asking the neural network, you only win the game when you manage to optimize all four at the same time. I'm going to show you now three scenario comparing the reactive system, which is a system that you have right now in the room where the conference is being hosted, and what the neural network is doing in parallel if he was operating that room. So this is a single zone. So I want to show you, basically, we want to compare the behavior between what the traditional control is doing, what I call the classic control, which is the dotted line, and what is the AI is doing in terms of controlling the temperature in that zone. And you see here, you're going to see that graph in the next couple of slides. So basically, it's a typical conference room schedule where during the night, and this is a time step every 15 minutes, during the night, we let the temperature fluctuate in a much larger range because there's nobody in the room, and doesn't matter if it's too hot or too cold. So we give a break to the system. And during the day, when there's people basically are in that room, you want to maintain a much tighter range. So that, and then at the end of the day, you relax the time again. So you're going to see that, and we're going to compare each of the two scenario. So you see here that the classic control is reacting as soon as he's hitting the line, and he's trying to maintain it. And you have the behavior of the AI neural network operating the same room in the same day. And you have on the side here basically the number of minutes that we went out of the comfort zone, the classic and the AI. As you see, the AI managed to improve the comfort. The quantity of power being consumed in a peak load was the same. The quantity of kilowatt hour managed to reduce by 1,000, and the running time of the equipment was lower. And at the end of the day, there was about $100 saved. Now, we're going to look at what happened if you increase the number of zones, because controlling one zone, one conference room is one challenge. But as you start to have multiple zones, it's starting to be more and more complex because you want to manage all of them in an holistic way. So here you see with two zones, what's happening. So the AI is managing both zones in parallel. He's trying to basically save the money for the total of the two zones, and he's trying to optimize all of the four axes that I described. So you see improving comfort. In this case, it managed to stage the two zones and start to do like a teamwork and managed to reduce the peak load by about 100 kilowatt. and still managed the number of kilowatt hour being used. The runtime was increased. So he managed to increase the runtime, but it never triggered stage two. And I'm not going to dive on that for lack of time, but it basically reduced the consumption of energy. And of course, the total bill was reduced. Now let's look at 7 zone. And that's basically my key message is when you start to have 7 zone or higher, and think of like a typical office building might have 200 zone. How do you manage 200 zone without these type of tool? Well, you're doing your best. With the AI, he's optimizing all of these zone in this at the same time at every time stamp because he's looking at all them and he's trying to basically different combination, trying to manage and optimize all of its 4 axes. And that's where you start to see significant dollar showing at the bottom line, where the AI is operating that building in a better fashion. And 7 zone is really like usually not just a floor. So imagine if you have 200 zone, what kind of value the AI is doing. So it's very similar than the autonomous car in that fashion. So just to show you what type of value, this is an office tower in Montreal, managed to save 21% of energy. An hotel, which is operating 24/7, so there's more energy being spent, but at the same time, more opportunity to save 43%. And even in retail, small stores, where there's several of them located in different part of the city, saving an average 20% saving.